Okay, good morning. Welcome to
MathyMath115a.
So today we were looking at some of the review sections in Chapter 2 of Art of Problem Solving's algebra book, and it asked about this sum. And do you remember what this sum equaled? 1 plus 2 up to n?
It was n times n plus 1.
Okay. You can make that 2 a little more 2e. And so one way they ask you to check this isn't a complete proof, but they said add n plus 1 to both sides. And so how does that help you check? I want to see if you understood what they were getting at.
Well, it would make this sum different.
Okay.
So like, you say 1 plus 2 plus n plus 1 equals n times n plus 1 over 2 plus n plus 1.
Okay, good. And what else should it equal? What different expression than this should it equal?
It should equal n squared, well, no, it should equal n plus 1 times n plus 2 over 2.
Right, so if this formula is true, and we change n to n plus 1, this should equal n plus 1 times n plus 2 over 2, which should equal this if we just add n plus 1. So how can we check that?
Well, you can just do like a bit of simplifying and multiplying. So, you n, well, I'm going to multiply this out to be n squared plus n plus 2n plus 2 over 2.
Okay.
Then this is n squared plus 3n plus 2, whole thing over 2, which n squared plus 3n plus 2, it's n plus 1 times n plus 2.
Okay, how do you know that?
Because so when n plus 1 times n plus 2 is multiplied out, you get this.
Okay, cool. n plus 1 times n plus 2 all over 2. And that's kind of what we were hoping for. And let me just show you something real quick, and then we're going to talk about how this relates to the Aztec circle theorem we talked about yesterday. Believe it or not, there's a funny connection. But the other way you can look at this is you can actually factor an n plus 1 out right from the start, n plus 1, because it's in both terms. And you're left with n over 2 plus 1. You factor out.
So that would be n plus 2 over 2.
Right, so then you end up with n plus 1 times this becomes n plus 2 all over 2. So that's another way. That's another way you can see it without multiplying it out. But, as I said, believe it or not, this actually relates to the Aztec circle theorem. So let's just, funny little coincidence, let's just take a quick look, okay?
Alright.